We have been looking at the properties, specifically the mathematical properties of the shortest path distances. Let G is a graph with vertex set E, edge set E, weight function W and a source vertex S. Let us assume that this is the instance of a single source shortest path problem, and let delta V is the weight of shortest path from S to V. These notations we have introduced already, and suppose we have an edge uv. You have the value delta u associated with this and the delta v associated with this. We have seen that if delta u plus weight of uv is less than delta v, if this is the case, then G has a negative cycle. If delta u plus wuv is less than delta v, then G has a negative cycle. We are going to look into a kind of a converse for this. That will be our next theorem. If G has a negative cycle, then G has an edge uv such that delta u plus weight of uv is less than delta v. So, if the graph has a negative cycle, then there is an edge satisfying this property. If there is an edge satisfying this property, then G has a negative cycle. So, this is a kind of a characterization. Okay. So, how do we prove this? It is a kind of a converse. This is an important theorem, and the proof technique is also pretty canonical, in the sense these kind of arguments we will use often in the course of our discussion of proofs for other theorems. Okay. The proof is by contradiction. This is by contradiction. Suppose for all edges, right, what is the negative of there exists an edge? It is a negative is for all edge. Proof by contradiction. Suppose for all edge uv we have the following: delta u plus weight of uv is greater than or equal to delta v. I am assuming this for the sake of contradiction. You will see that since G has a negative cycle, let C be a negative cycle of size k. So, let us say it starts with V0, V1, V2 and so on, Vk, where Vk equal to V0. It is a negative cycle. I have given the list of vertices of the cycle: V0, V1, V2, V k minus 2, V k minus 1, next is V k, the same thing is V k. It is a cycle, end to end connection. So, the same vertex has got two notations V 0 and V k, because it is an end to end connection. We have V k is same as V 0. If it is an open path, the starting vertex and the ending vertex would be different, because it is a cycle. By our notation we set V k equal to V 0, and this is how the scenario is. Note that this is a negative cycle. Since G has a negative cycle, we have taken a negative cycle C, and these are the edges of the cycle. We know that for each edge, okay, the condition that we have stated, look at the condition, what is that? Delta u plus w u v is greater than or equal to delta v for an edge u v. So, for V 0 V 1, delta V 0 plus weight of V 0 V 1 is greater than or equal to delta V 1. For the edge V 0 V 1, this is true. For the edge V 1 V 2, delta V 1 plus W V 1 V 2 is greater than or equal to delta V 2, and so on. Finally, the last one, delta V k minus 1 plus W V k minus 1 V k is greater than or equal to delta V k, because for each edge this is true, for the edges in the cycle this is true. So, we have k inequalities. Adding all these inequalities, we get the following. This is sigma I equal to 0 to k minus 1, because V 0 V 1 is there, delta V I plus V 0 V 1 is an edge of the cycle, V 1 V 2 is an edge of the cycle. So, these are all the k edges of the cycle. The cycle has got k edges and the weights of this, therefore, this is weight of the cycle C. This is greater than or equal to sigma I equal to 1 to k of delta V I, because here you have V 1 V 2 V k, I goes from 1 to k. So, adding all these inequalities, we get another inequality. Since V k equal to V 0, these two are equal. Actually, this expression and this expression are equal. Okay. Why? Let us see. Delta V 0 plus delta V 1 plus delta V k minus 1 is equal to V 0 is same as V k, therefore, this is delta V k plus delta V 1 plus delta V k minus 1. Move the V k term to the end, you will see that this is delta V 1 plus delta V 2 plus delta V k minus 1 plus delta V k, all right. Therefore, these two sums are equal, all right. This implies sigma I equal to 0 to k minus 1 of delta V I is same as sigma I equal to 1 to k of delta Vi. Because these two are equal, we cancel this, equal terms can be cancelled, and you get this implies W of C is greater than or equal to 0. Why this is greater than or equal to 0? I cancel these two equal terms. Okay. So, this term, the term on the left and the term on the right are cancelled, but this is a contradiction. Weight of the C is greater than or equal to 0 is a contradiction. This contradicts the fact that C is a negative cycle. C is a negative cycle. This implies not all edges will have this property, its negation. This implies there exists an edge uv such that delta u plus weight of uv is less than delta v. We have proved by contradiction the statement of the theorem. Okay, very clean and simple proof. So, theorem 1 and 2 imply the following: G has a negative cycle if and only if there exists an edge uv such that delta u plus weight of uv is less than delta v. This is the first mathematical property. And what is the implication of this mathematical property? If G has a negative cycle, then the delta u and delta v and all are not related by any equation. Okay? There is no specific relation, one as an upper bound. Some of the neighbors may have larger value, some of them have a smaller value, and it could be anything. So, we are not able to say precisely anything about the values delta v. What would you generally expect? Just a common sense requirement. If uv is an edge, if S is a vertex, suppose this is the shortest path, if this is the shortest path and if this is the last edge, how would you have reached u? Just a common sense thinking. You will not wander around and reach u. The way in which you would reach u from S must be a shortest one. Ideally, this is what you would expect. So, you would expect a kind of a relation where you have something like delta u plus weight of uv is equal to delta v kind of a relation. And if this is the shortest one, if you reach any other way, right, suppose you reach from some other vertex, some u dash, even if you have taken a shortest path to u dash, that path it is not shortest path, it is longer than that. Therefore, you would expect delta u dash plus w u v is greater than or equal to delta v, right. If you reach v in any other way, that will define a longer path, but if you reach via u, that is going to define the shortest path. Any other way is going to be longer. Therefore, this will be the shortest. This is a kind of a intuition. This is what we would want, right. In other words, we would want something like intuitively we want something like delta u plus weight of u v is greater than or equal to delta v for all u v in E, any last edge, right, and there exists an edge u v such that delta u plus weight of u v is exactly delta v. This what we would intuitively want. If this is the case, then we can write something like delta v equal to minimum over u v belong to E such that delta u plus weight of u v. Calculate all these values, take the minimum, you will get delta v. Pictorially, suppose this is v and from u1 there is an edge, from u2 there is an edge, from u3 there is an edge. For u1 calculate this, for u2 you calculate this, and for u3 for every incoming edge, assuming that I have the information related to the shortest path, the distance to the neighbors, then I can find the distance, the shortest weight of the shortest path to v, because it is just going to be the minimum. This is intuition, right. This is what ideally we would like to have. I mean, if it is there, then we can kind of proceed, but that is not going to happen if G has a negative cycle. If G has a negative cycle, you can see that there are edges for which these kind of inequalities do not hold good, right. Therefore, we are going to work only with graph that do not have negative cycle. Okay. If G has a negative cycle, then even if I have the information about all the shortest paths to the neighbor, that is not enough to find the shortest path to V. In other words, I have V, I have from U1, I have information delta U1, I have U2 and I have delta U2, this information. Like this, I may have several neighbors and I may have information about them. Still, that is not enough to find delta V. A shortest path from S to V must have a last edge ending in V. It should be one of these edges, u1v or u2v or u3v, one of the edges must be there, the last edge. However, none of these edges are helpful in finding the shortest path, because if G has a negative edge, we do not have any inequalities. We do not have a specific relation. Okay? Therefore, if G has a negative cycle, we are unable to determine the weight of the shortest path in terms of the weight of the shortest path of its neighbors. Okay? So, we assume that G has no negative cycles. In fact, we can show that no efficient algorithm is likely to exist if G has a negative cycle. If G has negative cycle, then finding the shortest paths and shortest path distances is NP complete. It is a very hard problem, alright. We have no way of solving them efficiently. NP complete means there is no hope that we will be able to find a polynomial time algorithm for it. Therefore, the assumption that G has no negative cycle is becoming important even from the complexity theory point of view. Okay. So, what are the immediate consequences of assuming that G has no negative cycle? If G has no negative cycles, 1, contrapositive of theorem 1 is true. That means for every edge, for all uv in E, delta u plus weight of uv is greater than or equal to delta v. A property that we were looking for is true. Okay. The second most important property, that if G has no negative cycle, there exists an edge uv such that delta v is in fact equal to delta u plus weight of uv. This property alone is not enough. They all provide the upper bound. Delta v is smaller than these quantities, but what is the exact one? It is smaller than all these quantities, one of them is equal, therefore it is the minimum of these kind of quantities, right. That is the conclusion we get the moment we prove this. So, this is the next important theorem. If G has no negative cycles, then there exists an edge uv such that delta v equal to delta u plus. This is the statement of the theorem. So, if G has no negative cycles, the contrapositive implies these inequalities, but they provide only an upper bound. This does not give still a formula. In order to have a formula, we need one more result. In other words, if G has no negative cycle, we are going to show that there exists an edge uv such that delta v equal to delta u plus wuv. We will see the proof of this theorem in our next session. Thank you.